We're going to continue with this section on using algebra to solve problems. And these next few examples, we're going to maybe scale it back a little bit, not look at quite as complicated algebraic equations. In this first one, it says Maria picks an integer. So an integer can be positive or negative, just cannot be a fraction. Divides it by 2, and then adds 12 to what she has. When she tells you that she now has 10, can you tell her what integer she started with? You certainly can. So you can go ahead and create an equation here and then solve it. I'm going to let n equal her integer. So we're told she takes that integer, divides it by 2, then adds 12 to what she has. And it says she now has 10 when she does this process. Can we tell her what integer she started with? Why, yes, we can. We're just going to solve this equation for n. So we subtract 12 from both sides. N divided by 2 then is equal to negative 2. And then multiply both sides by 2. We find that her integer is negative 4. So we can find her integer very easily. Now, she does this again. She said she wants to trick her teachers this time. So she picks an integer, multiplies it by 2, so that's 2 times her integer, then adds 12. When she tells you that she now has 15, can you tell her what integer she started with? Why, yes, it's just solving this equation. So I'll subtract 12 from both sides. That leaves us with 2n equals 3. This time we're going to divide both sides by 2 because we have 2n. And we end up with 3 halves, so we're able to find the number that she started with. However, it is not an integer. We have here a rational number. It's a fraction. Moving to the next page, we're going to look at somewhat famous problem, the chickens and the goats. It says Old MacDonald has 100 chickens and goats all together in his barnyard. In all, there are 286 feet. How many chickens and how many goats are in the barnyard? There are many ways that you could solve this problem. I actually do a very similar problem to this in a quantitative reasoning class, where sometimes people will draw pictures, sometimes people will do a table, sometimes people will do guess and check, but we're going to use algebra. And in this case, we're going to do 2 equations with 2 variables. I'm going to let C represent the number of chickens, and G is going to equal the number of goats. So we're going to do 2 equations here. We're told that he has 100 animals. So the number of chickens plus the number of goats is going to equal 100. And then it tells us there's 286 feet. So the chickens have 2 feet. So to get the number of feet for the chickens, it's going to be 2c. The goats have 4. So 4g will be the number of feet there, and that's going to equal 286. So we now have 2 equations, 2 variables. We can go ahead and solve these. There's a couple different ways that you could solve these. You could graph them and find the point of intersection, or you could solve it algebraically, which is how I'm going to do it. In my notes on Blaze View, I took the first equation and I solved it for C and then substituted that into the second equation. And if you look at those notes, you can see that process. I'm going to do the example here a little different just to show you there's a couple ways that you could do this. I'm going to use what's called the addition or sometimes elimination method. We're going to ultimately add the 2 equations together to eliminate a variable. So what I want to do in this case, you've got options, but what I'm going to do here is I'm going to get rid of my c's. Since I have 2c in the second equation, I want to have a negative 2c in the top equation. So to do that, I'm going to multiply that top equation by -2. So when I multiply that top equation by -2, I get -2c minus 2g equals -200. So now when I add my equations together, I'm going to eliminate the c's. So I get 2g equals 86. Divide both sides by 2. So I have 43 goats. I know that there's 43 goats, so to find the number of chickens, I can actually go back to either of the original equations. I think the first equation is a little simpler. C plus G is 100. To find the number of chickens, C plus 43 equals 100. Subtract 43 from both sides, so I get 57 chickens. And if you plug in the 57 for C and the 43 for G into that second equation, you can verify that it is also going to be true. So 43 goats, 57 chickens. And the last example I'm going to do in this video says Dana received grades of 78, 86, and 94 on the first 3 exams. For an A, the average on the 4 exams must be at least a 90. What can Dana do to get an A? So to find the average, we're going to add the 4 exam scores and divide it by 4. Technically, it's the mean if you're dealing with statistics here, but that's what we're talking about when we say average. But we don't know what this last test score is. So we can use whatever variable we want. I'm going to let T represent the score on the 4th test. So to find the average, we have 78 plus 86 plus 94 plus T divided by 4. And that has to be at least a 90. So we want it to be greater than or equal to a 90. So we need to solve for T. So I'm going to do 2 things at once. I'm going to first multiply both sides of this inequality by 4. On the left, it completely gets rid of that denominator. On the right, we just get 360. And at the same time, I'm going to add 78, 86, and 94. If you add those together, you get 258. So 258 plus T is greater than or equal to 360. To solve for T, subtract 258 from both sides. And that means that the 4th test score has to be at least a 102. So what can Dana do to get an A in this class? Well, Dana would have to get a perfect score on that last test, plus somehow get 2 extra credit points. In other words, probably not likely that Dana is going to get an A in this class.